conceptual modeling design, ER diagram, logical modeling and design, relational schema, physical modeling and design, structured query language, database management system or DBMS implementation, and references. Let's start with the first topic. So this is an overview about my project. So I'm trying to build a CI/CD application. The presentation is to display my understanding of database principles I learned in this course. On a high level, I learned that database is mandatory in software development lifecycle process. I particularly learned about concepts like determining the purpose of the database, designing database schema, gathering the required information of the business, converting this information to data by structuring them into tables, specifying relationships between tables, and normalizing data for better results and reports. Let's move on to the next slide, which is conceptual model design. This offers a standardized business view of data needed for business processes, business activities, and related performance indicators. The aim of this model is to define the data used in business, but not their processing flow or physical properties. The three basic concepts of conceptual data model are entity, attribute, and relationship. Entity is a real world thing, attribute is the properties of those entity, and relationship is how two entities are associated with each other. So this is all about conceptual model design. In the about diagram, the customer and product are real world concepts, so they are entities, and they have attributes like customer name and product name, and sales is their relationship. Moving on to the next topic, ER diagram. In the ERD diagram, above project, build, package, deploy, Artifactory, and assembler are entities as their real world concepts. Project has attributes like name, representing the name of the project, programming language, and build has attributes like build tool name. Similarly, other entities have their own attributes, and they have relationships like one-to-one and one-to-many. Let's move on to the ERD next concept. Next concept is logical model design. A data bank of continuous integration and continuous delivery screenshot is seen here. The two abbreviations are commonly mentioned as CI and CD. CI is plain synonymous with continuous integration, a process that encourages preparation to release. However, a CD can mean non-stop transmission or continuous transmission, and seeing that both activities share much technically. There is also an immense difference between them, which have their fundamental implications. Anyhow, logical model design finally is laying out the conceptual design into a logical format to design the database. Moving on. Relational schema. Schema is the design of the database. It defines the structure of the database and its tables. In the above screenshot, we created a database called Continuous Integration and Continuous Delivery. It has 6 tables: project, build, assembler, package, deploy, and Artifactory. The schema of this table explains that project commit ID is the primary key of the project table, and it also is the foreign key in the build table. So all these details and the constraints, including the not null constraints, contributes to the relation schema. Moving on. Next topic is physical model design. It is relatively straightforward to convert the relevant database structures into physical databases from a logical model. How to translate includes the following rules. Entities become tables in the physical database. Attributes become columns in the physical database. Choose an appropriate data type for each of the columns. Unique identifier becomes columns that are not allowed to have null values. So that's about the relational schema. Next, moving on to SQL. The above screenshot shows a bunch of SQL queries. A couple queries form a transaction. Transaction is nothing but exchange of queries. For database, transaction should be smooth and productive so that there is no data loss, and to ensure this they must be following the ACID properties, which means atomicity, consistency, isolation, and durability. Moving on to DBMS. In order to promote data organization and manipulation, the DBMS program acts mostly as an interface between the end user and the database, and at the same time controls data, the database engine and database schema. Although the function of DBMS differs greatly, the DBMS functionality and abilities should include a user accessible catalog detailing metadata. Next is DBMS implementation. So I used MySQL as my DBMS, and the editor I used for MySQL is MySQL Workbench. The screenshot shows how I used MySQL create statements to create the table. You can see the table in the below half of the picture. I also used MySQL insert statements to load the data into the table. So this is my implementation of DBMS. Finally, concluding, CI/CD is part of software creation and implementation. There is very important need of DBMS in CI/CD. DBMS has advantage over a conventional file system, ideally tailored to massive networks, data shareable, versatile, data confidentiality, and a complex backup system. So these are the references I used to create my presentation. One of the most important is the database system implementation textbook. This is all about my presentation. Thank you for bearing with me. Have a good one.